Hi, my name is Benjamin May, and this is my final coding project for CSC 151, Road Trip and Application, Graphs, Queues, and Planning the Perfect Road Trip. So my outline, I'm gonna go over the problem description. So like the kind of the problem that I have, the possible solution, and the data structures used, tools and technology used, the demonstration of the basic operations, discussion of what I learned and potential future applications, references, and honor code. So problem description. So why don't you road trip? The problem with a road trip is that it takes a lot of time for planning and researching before you can go. So if you're going on a 6-day road trip across country at every city all along the route, you have to look at the different places available, compare user ratings, star ratings, read about it and make these selections. And if you're a student, just got done studying for finals, or you're a worker, have a career and you're working 60+ hours a week, maybe you don't have the time to kind of do all this research and planning for the road trip. So it might just be easier to book a hotel in Florida and hang out on the beach for a week, right? But can we solve this problem? So is there a better, faster, easier way to plan your road trip? Well, now there is with the RoadTrippin application. So the RoadTrippin app, it's as easy as 1, 2, 3. So you create a user profile with your name, username, and the interest category that you're interested in. Input the starting and ending locations of the road trip, and the RoadTrippin app does the rest of the work for you. It'll select your customized road trip location based on your interest and the star ratings of the available locations along the route, and it'll output that information for you. So the data structures used in this project, I try to select the data structures that are the best way to handle this problem and solve it. So since we're talking about kind of like a map with different locations and a route that's connecting these locations, I selected the directed weighted graph, where the nodes or the vertices in the graph are the location objects, and then the edges are the route that's connecting these along the way. So I also use a linked dictionary. This data structure is used within the graph class, or the graph class implements it, and the dictionary is used to store the different vertices in the graph. Then we use a queue as well. So this is used for traversing the graph via our breadth first search. When you're exploring all the different locations that are possible options for your trip, it uses the queue to do that traversal. And then also use a linked list with iterator, which is used for adding the edges between the vertices in the graph. So tools and technology. So since I built all of the different data structure classes, like the directed graph, the queue, linked dictionary, linked list with iterator, so on, I built those all myself using the interfaces and information from the textbook in our course. So the main technology I used was Google Slides, the shapes and arrows portion to create the visualizations of the graph, which you will see here shortly. So demonstration of the basic operations. So first you create a user profile by creating a user object. So you're just gonna take the user's full name, username, and then their category of interest. So we use Scanner to do that and allow the user to input their full name and username. And then it allows the user to select from a list of different interests they can do. And the reason we have them select from a list here is so that the interest they select matches exactly the different categories of the location objects, and it's not some like random interest of theirs that doesn't really match anything. It doesn't help with their road trip planning. So next, create location objects for the map. So to make the code look a little bit nicer, I put all the location data in an external text file, and then we use Scanner down here to read in the data from that text file. And as you iterate through all the data in the text file, it creates the different location objects. So it puts those location objects in and then adds those location objects to a location list or a location array, which we're going to use later to build the graph. So for the location object, you need the location name, the category, which match the user interest categories, and then the star rating, which is going to be used for the weight of the edges in the graph. So now creating the actual map, what we're going to do, first we have that array of location objects I mentioned. So we're going to iterate through all the location objects in the array, and we're going to use the add vertex method, which creates a vertex in the graph class. And that this add vertex method actually calls an additional method for the vertex class, which is going to create those vertices. Then we're going to add the edges between the different vertices. So the way the graph is laid out, if you're starting location, and then in each layer of the graph, there's a maximum of 5 location objects or location vertices stored in there. And so those layers essentially create the cities that you're going to be passing through in your road trip is a good way to think about it. And so that's where we go through, and this is where we add all the edges to the different layers. So For the visualizations you see, this is the key, the vertex key. So really when you run the program and you output your your road trip path, it has the actual full names of the different locations and all the information. But for this visualization, we can't fit the whole full name in here. But what's important is the category for this application, and the star rating is important to see how it actually works. So I created this key for the different categories. The letter represents it, and then the number here represents the star rating. So this is what the actual graph kind of looks like, a visualization of it when it's made. So you have your starting vertex, and then there's a directed edge going to each of the vertices in that first layer there. And then for each of these vertices, each vertex has an edge going to each of the vertices in the following layer, because depending on no matter which location you go to or selected in that first layer, you can still reach any of the next vertices in the next layer from there all the way until your end destination. But an easy way to kind of conceptually like think about this is essentially you have a layer or a city, and so you search all the locations in this layer, select one, go all the locations in the next one, select it, and so it's really just looking city by city is when you're doing like the work of the code. So now to get your actual road trip path, we use a modified breadth first search. So what we do is we traverse the vertices like layer by layer, so city by city along the way, and then you compare each of the locations in that layer and select the one that's best for the user. So how we make those selections, if there's only one location with a category that matches the user's interest, that location is automatically selected. If there's more than one location with a category matching the user interest, we then compare the star ratings of those different matching locations and select the highest rated one. If you come to a city where there's no location that matches the user interest category, then it just selects the highest star rated location. So essentially you're giving the user the best that the city has to offer, since there's nothing that they're interested in specifically. So how we do that, so we use a queue to do this breadth first search. So we put your starting location in the queue, and then we're gonna search all of the different neighbors, the nodes in the first layer after that. And then what we're going to do is we're going to compare all of those. So we have the best location variable here. We put the first location you check in there automatically. Then when we compare it to the next location that you look at, if the next location is better, it replaces the original location that was here in the best location variable, so on, make all the comparisons, and then you're left with just the very best option. And that is added to another queue, which is going to eventually be output for the user's path at the end. So then you just print the output. So you iterate through that queue that was returned with all the information. We use a queue again, so that way you can output the locations of the road trip in the correct order that you're going to come to them in. And so that's just what this code is doing here. So I made a few sample users so you can kind of see how this works. So the first one's just me, Benjamin May, username may be. I'm interested in science and technology. I'm going from Schenectady to Los Angeles. And so you'll see first I'm go to an ancient Egypt museum. It's a history 5-star rated. You'll see there's no science technology in the first city. That's why I got a highly rated non-science technology. Then I go to the science technology and so on and so forth, but we'll see that here in a second. So this is what the graph's going to look like for it. So I have the starting location. Again, you see there's no, the T, remember science and technology, there's no T locations in this first section, or this first city. So it just selects a highly rated 5-star rating down here, which is the history museum we talked about. In the second layer, there's 2 science and technology locations that we can visit, but it selects the 4-star because that's the higher of the 2 ratings. Third city, again, there's no science technology locations, so we just select a highly rated 5-star location. City 4, again, there's 2 different science technology locations, so it selects the higher rated of the 2, which is the 5-star here, then a 5-star science technology in the last city, and then you're on to your destination. So next, my second user is my best friend, Ember. So as you can imagine, she loves going to the park. So her interest category is parks and outdoor. She's doing the same route as me, Schenectady to Los Angeles. And so you'll see here, her graph is going to be slightly a bit different, her route that she's taking. So even the first one, remember mine was an ancient history museum. Hers is a 5-star rated hiking trail because that matches her user category and so on. So we can take a look at her actual graph here. So again, she goes to a 5-star park in the first city, a 3-star park in the second city. There's no parks in the third city, so she goes to a 5-star history location, and then a park in the 4th, 5th, and to her final destination. So you see, even though we're taking the same route, our 2 location, our road trip paths are quite a bit different here. So now road tripping in action. Oops. We'll go ahead and take a look at the code here. So first, over here on the side, you can see these are all the different classes and interfaces that I created from the book, which make this all run and function correctly. I have my user class that I created over here. I have my location class, and then here's the location data from the text file that gets read in. So now we'll go ahead and run this client file here. So let's do me. I'll say art for this one because we haven't looked at that yet. And then just for ease, I'll put here to there. And then here we go. So you see there's a lot of different like art locations on this one, which we haven't seen in the past. So there's the output for that. And now back to the presentation here. So discussion, what I learned in this project and for future applications. So one really cool thing I learned was how to implement these different data structures we've been reading about, talking about in this course all term long. And kind of getting to work hands-on with them and actually create a project with it. A really cool thing I learned was kind of using multiple data structures together to achieve an end result. So as we kind of discussed, like my graph class, it implements a linked dictionary. And also like the vertex class implements a linked list with iterator. Traversing the graph. So there's that BFS method within the class uses a linked queue. So these are multiple different data structures all working together to achieve our goal of creating this road trip path. And then also it's really cool to be able to think through a complex problem. I wasn't doing a quick like 3-inch block of code. You know, this was a bigger project. So I had to really think through the entire project and plan it out before I actually started coding, which was a new experience for me and was really cool to do. And then for future applications, you know, I'd really like to continue looking into this project, kind of looking into the possibility of a Google Maps API to make a fully functioning implementation of this, where it actually pulls in actual maps, actual location and data and star ratings and user reviews to do essentially what I'm doing in this project, but instead of using just generic location information, using the actual real world locations. Then here's my references. I mainly use the textbook to create all my classes. And then there's a photo on slide 3 that I use, and then the honor code. So thank you very much for listening, and thank you.